All right, so we're now moving on to our next unit, and this next unit is going to be about system of equations. And you may have heard this as simultaneous equations. They represent the same thing. It's just we use the American system, we use the American standards, and we call it a system of equations instead of simultaneous. So this next unit is all going to be about systems of equations and how to solve them. This video is going to specifically focus on graphing because graphing, although it may not be the best way of solving as far as like the fastest, and it actually can't be used every single time because we might start approximating answers if we're doing them by hand, but it's the one that I think will allow for us to truly understand what a system or simultaneous equations are, because we talk about graphing and what their graphs represent. So I think it will allow for us to visually see and understand, and then we'll move on to other ways that you can solve them as well. All right, this video I'm going to break up into two different videos just because I want to make sure that it's not too long for each one. And this first video, I'm going to be doing a lot of explaining what a system of equations are. We'll solve one problem in here by graphing, and then the second video is going to be a word problem. All right, so this way you can break up your videos and you don't have to feel like you're watching like a 15 or 16-minute video in one time. We can break them up for you. All right, but what you'll need to know at the end of this video is you'll have to know what a system of equations are. So when we talk about systems of equations, what are we talking about? Once again, you might have heard them as simultaneous equations, so you'll have to know what they are. And then the second thing that you'll have to know by the end of this video is you'll have to know how to solve a system of equations through graphing. All right, so it's a very specific method. Like I said, it's the one I think is best for us to talk about first so we can understand what a system of equations are. And then we'll learn some other methods that will be a little bit faster and maybe even a little bit easier for some of you to solve as well. But we're going to talk about this first in the video, do one example in this video, and do a word problem in the second video. All right, so what exactly is a system of linear equations? And a system of linear equations is where we have two or more equations that represent the same variable or same variables. So meaning that what the answer is for x, y in this first one. So if I say x or whatever the answer is, the same x and y have to be the same answer for the second equation as well. So when we're solving a system or simultaneous equations, we're looking for solutions that satisfy both at the same time. So we can kind of think about it as an and statement because it needs to satisfy the first equation and the second equation. So we're looking to see which solution satisfies both of them at the same time. And what's really, really crucial that you need to understand is that this x represents the same x or unknown in the other equation. And this y represents the same y or the same unknown in the second equation. They represent the same thing. If this is confusing you right now because there's no context to this, when we do the word problem in the second video, you'll see that, okay, this makes a lot more sense once we see context behind this. But know that the x in both equations must represent the same thing. And since they represent the same thing, it must be the same answer in both. And then the y's represent the same thing in both. Therefore, it must also be the same answer. So whatever answer we get for this first equation must be the same answer for the second. It has to satisfy both of them at the same time. All right, so a solution, as I was just talking about, of a system of linear equations and two variables is an ordered pair that is a solution of each equation in the system. So it needs to be the solution for both. All right, so remember, when we were learning this before, we graphed the equation. Let's just imagine that here's our coordinate plane. And I'm just going to quickly just say, okay, I'm going to graph this first equation 1 in green. Let's just say it looks like this. Remember, every single point on that green graph would satisfy this equation. So we have an infinite amount of solutions for that equation, y is equal to x plus 1 when we graph it, because we can pick all those different points. All right, but when we're looking at a system, we're looking at an equation that satisfies both of them at the same time. So if I go to graph the second one, let's just say that the second one looks something like this. If I go to graph the second one and all those blue points on the blue graph satisfy our blue equation, well, when we're looking to see which one satisfies both at the same time, think about it as an and statement. And when we were dealing with our inequalities just in the last unit, when we said and, we were looking for overlap. We were looking for intersection. So when we're graphing, we're looking to see, okay, which point do both of these graphs share? Because that ordered pair is a solution to the blue and a solution to the green. Right? If we were to pick some ordered pair all the way up here, well, yeah, it satisfies the blue, but it doesn't satisfy the green because it's not on that graph. And if I were to pick a point here for the green, it satisfies the green equation, but not the blue. So when we're looking at a system of equations, it must be that it satisfies both of them at the same time. So we can think about it as an and statement that we were just doing. So when we're graphing, it's simply just graph both equations and look and see, okay, what do they share? What point is the same in both? All right, so let's go ahead and do an example. All right, so just so you know the different ways that it can be presented to you, the directions could flat out say solve the system. So when you see that, you know that means, okay, these two equations, we must have the same answer for both because we're treating them to see, okay, what answer satisfies both of these at the same time? Or the other way you can see it denoted is if we draw a brace around these, we're saying we're looking at these two equations together. Right, so I can flat out tell you, solve the system of equations, or I can write it as a brace, and that also represents that this is a system. All right, I'm going to graph this first equation in blue and the second equation in green. So when we're solving a system of equations, it's pretty simple and straightforward when we're graphing. We just graph each of these equations. So y is equal to 2x plus 5, and y is equal to negative 4x minus 1. We just graph each of these individually. All right, when we're graphing them, first thing we do is find our b, which in this case is 5, so 0, 5. And then our slope is equal to 2. And remember, since it's change in y over change in x, we do oftentimes want to write this as, a fraction of 2 over 1. So my change in y is a positive 2, and my change in x is a positive 1. So let's go ahead and graph this line. Remember, first thing we do is plot our y-intercept. So we plot that b. And now our change in y is positive 2, so I'm counting up 2 and over 1. All right, you will use a straight edge to graph this, and you want to plot as many points as you can actually on this one. Just be a little bit better for you to make sure that your graph is drawn perfectly straight. And I'll explain why in just a few moments. But I'm going to pause this video and finish drawing this line. Since I can't use a straight edge on this, I need to plot all the points I can. All right, so there's my graph of y is equal to 2x plus 5. And remember, every single order pair that I get on this graph is a solution. If I pick this order pair here of negative 6, negative 7, and I plugged it in, that will be a solution and that will work because negative 7 does this equal to 2 times negative 6 plus 5. Well, 2 times negative 6 is negative 12, plus 5 is also negative 7, so yes, we know it works. So every single point on that blue line is a solution to our blue graph. All right, so now, when we're dealing with the system, we're looking at these together, so we need to graph them on the same coordinate plane. So same thing, b is equal to negative 1 in this case. So it gives me the point of 0, negative 1, so I'll plot that. Our slope is equal to negative 4, which we'll write negative 4 over 1. So we have our change in y over change in x. So my change in y is telling me I'm going down 4, so 1, 2, 3, 4. And my change in x is telling me a positive 1, so I'm going over 1. All right, once again, you'll use as many points as you can, but also a straight edge to draw this nice and good and straight. And as perfect as you can. And I'm going to go ahead and pause this so that way I can fill in the rest and draw my graph. All right, so there is my green graph that represents the green equation that I had. Remember, every single point on the green graph is a solution. So whatever I pick, I can plug it in and I know it'll work just like I did here. So we're looking to see which one satisfies the blue equation and the green equation at the same time. So just like we did with our inequalities, we're looking for the overlap. We were looking where they intersected. We were looking where they shared. So the point that they share is where they both, where the two graphs intersect. Because if I were to highlight, if I were to highlight this point here, that point is part of the blue graph, and it's also part of the green graph. So that tells me it's a solution to both. If I were to pick any other point on this green graph besides that one, it won't be a solution for the blue, so it cannot work. Yes, it may satisfy this one, but it wouldn't satisfy this one. And the same thing, if I pick any other point on this blue graph, it'll satisfy the blue equation, but not the green. And since we need it to satisfy both at the same time, we're looking to see where they overlap. And that's where they intersect. So if we look here, it intersects at negative 1 for x and positive 3 for y. So that means the only point that'll satisfy both of these at the same time is negative 1, 3. And now we can check our work. So negative 1, 3, we're seeing, is this a solution? So I'm going to plug it into the blue equation. 3, does this equal to 2 times negative 1 plus 5? Does 3 equal negative 2 plus 5? And 3 does equal 3. So we see, yes, it works for the blue equation. And now let's plug it into the green one. Does 3 equal to negative 4 times negative 1 minus 1? Does 3 equal to 4 minus 1? And 3 equals 3 as well. So yes, it satisfies the green equation. So you see this ordered pair satisfied both of them at the same time and is the only one that can, because it's the only part that they intersect at. Every other point will either only satisfy one or the other. And we can think about a system of equations as an end statement that it must satisfy both at the same time. All right, that is it for this first video. And then the second video is just going to be a word problem. And if you're having trouble understanding how the x and y can represent the same thing in both of these, this word problem should hopefully help you understand how the variable represents the same number and the same thing in both of our equations.